Alternating current fundamentals. Number 1. Magnetism and electromagnetism.
Electricity is used to meet the world's constant demand for energy. Whenever you flip on a light switch, prepare a meal, or simply relax in front of the television, you depend upon this vital source of energy.
Much of the electrical power used in the world today, up to 90%, is alternating current, or AC. The use of AC influences almost every aspect of today's technology, from the computers in this classroom to the cellular telephone in this car, wave ovens to satellite communication.
There is hardly an aspect of your everyday life that isn't influenced in some way by AC. The widespread utilization of AC can be grouped into 3 general categories of usage: for electrical power, for electronics, and for communications. Let's take a closer look at each one, beginning with electrical power. This is the type of AC usage you're probably most familiar with. Many devices, motors, appliances, and machines access alternating current directly for power through being plugged into a wall outlet.
The second general category of AC usage is for electronics, which uses alternating current in a different way. Here, the incoming AC signal is not used directly, but is altered. Although AC power enters the unit through the power cord, as in the case of this VCR, it is immediately modified by certain components so as to be useful to the microcircuitry.
A third general category of usage is communications. AC is capable of producing radio waves, which can carry information through space. This kind of AC makes satellite communications and space exploration possible, as well as operating the remote control devices used in model cars. Cellular telephones communicate with each other using this type of AC too.
Let's begin our exploration of AC fundamentals by looking at magnets. Without magnetism and its relationship to electricity, all of the electrical devices and applications just mentioned would not be possible.
Knowing the properties of magnetism will help you in your understanding of alternating current. In this video, the physical aspects of magnetic fields will be presented. The relationship between magnetism and electricity will be introduced. You'll see what an electromagnet is, and you'll be introduced to some common electrical devices that depend on magnetism for their operation.
The first known magnets were found in a natural state. These were stones composed of iron ore called magnetite, which had the unusual ability to attract small pieces of some metals. Today, there are man-made magnets. These are more powerful and more conveniently shaped.
No doubt you've seen how a magnet can influence certain metal objects at a distance. This is because it has an invisible, three-dimensional force field surrounding it, known as a magnetic field.
Iron metal filings can be used to show the magnetic field. Here, a bar magnet is placed under a piece of paper. Then, iron filings are lightly sprinkled onto the paper over the magnet. Because the iron filings are a magnetic material, they arrange themselves along the paths of the magnetic lines of force. Notice the distinctive pattern of the magnetic field. Here's a two-dimensional graphic representation of a magnetic field using dashed lines. But remember that a magnetic representation of a magnetic field using dashed lines. But remember that a magnetic field in reality is three-dimensional.
Magnetic fields have some very specific characteristics which play important roles in the production and use of alternating current. Let's see what they are.
Magnets have polarity. Polarity means that the characteristic of the force at one end of a magnet is different from, or opposite to, that of the other end. When this bar magnet is brought close to these iron filings, it's clear to see that most are attracted to the ends of the magnet. Most of the magnetic force is concentrated at the ends or poles of the magnet. There's a north-seeking pole, designated N, and a south-seeking pole, labeled S. These poles correspond to the Earth's magnetic poles. The Earth is like a very large magnet, with a North Pole and a South Pole.
Stop the program and complete activity number 1. When finished, continue watching the program.